All right, we're back. Let's get into it. So, new example. In this one, we're going to find the original score. So we're putting things back into the original units when we're given a z-score. So what does that look like? What does that kind of question look like? Well, let's say a professor at UW prefers to report grades in standard deviations. That's also just a z-score. Don't forget. So standard deviations from the mean rather than the raw scores. Okay. Thankfully, you know how to convert these z-scores rather easily. Your friend who sits beside you in the class doesn't, and they want you to do it for them because they're lazy. So whatever. So we've got the information below. So we see here that on whatever test, the average on the test was 73, and the average deviation away from that value was 6.8 points, I guess. And our job then is to convert our z-scores that we got. So our reported grade was as a z-score rather than the raw score. We just want to convert that back into the raw grade. Okay, so before we do that, let me show you, if you're confused on how we can do that, let me show you the original z-score. Let's see. Yeah, so the original formula looks like this. And actually, let me write it a little bit. Let me write it down here. Okay, so z equals our value, right, the original, minus the mean divided by standard deviation. Easy enough, right? We've seen that forever now. But I want to get this value by itself because that's the score that I need. That is the original units used, right? We're given this. We need to get back to this. So let me show you how we can go about rearranging this formula here. So let me get rid of that and let me do this in a different color. So what I want to do is, well, first makes sense from algebra. I want to get this out of the denominator. I want to get the standard deviation out of there. So what I'm going to do is I'm going to multiply that on both sides, so those will cancel out. Easy enough. Okay, so then that leaves me with, I'll put them in parentheses just to make it clear, equals x minus mu, okay? And then what I want to do, is I just want to move this, this mu over here. Okay, so that leads to, I'll draw an arrow here, I'll draw it back over here too. Okay, so that leads to then mu plus z times standard deviation, and then x. Easy enough, right? So if we go way back, I think I might have it out of order, but it doesn't matter. Yeah, here we go. So that's our formula, right? And this could also be mu, and this could be sigma. Don't forget. Doing the same thing, just a different context. And it looks like I'm all good, right? So that's just the math. That's the algebra to work that out. So I'll write that up here so I don't forget. So mu plus z times the standard deviation. Easy enough. That equals x. Okay, so I'm going to erase all this. Give me a second. Bear with me. See, you can fast forward through the videos, which is so nice. I have to live through it. Okay, so we're good. We're set. All we need to do is plug and chug, pretty much. Okay, so let's see. I guess we'll start with ours. So already we can see here that my score was 2.13, or not mine. Your score was 2.13 standard deviations above the test, above the class mean. For instance, and your friend is negative 1.58 standard deviations below the mean. Okay, easy enough though. So all we need to do is plug in the correct values. So the first one, so this will be for you. Okay, so 73 plus, and then your score, your z-score times then the standard deviation. Right, and that's just a product of moving some stuff around. It's nothing fancy, nothing new. So let me get out my calculator here again. So 2.13 times, let's see, 6.8. Okay, So, and then I'll just add. I'll do this all in kind of one swoop here. All right, cool. So that equals 87.484. So we'll just leave it as this 0.48. Okay. So you got an 87.48 on the test. And let's check out your friend score. So, friend. Easy enough. Okay. You've got a friend in me. Gosh. I saw Toy Story a couple of days ago, and I just can't get that song out of my head. Anyway. Okay. So, 73. Okay, that's the mean here. That's the mean. That's the class mean. Okay, and then what else do we need? Well, we need your friend's z-score. So negative 1.58 times 6.8. So that's all the same, right? This and this are all the same. It's just the one z-score that changed. Okay, so let me do this. 1.58 times 6.8. Okay, so that's negative 10.7, and then we just need to add 73 to that. And it looks like 62.256, so we'll round that up to 62.26, okay? So that's that. So that's your grade, that's their grade, back onto the original units, right? Back onto the original units. So we were able to see here that, well, I scored 2.13 standard deviations above the mean. My friend scored negative 1.58, right, away from the mean or below the mean. But we don't really know how that is scaled, right? We don't know how much that really is because we need to put them back into the original units, and that's what we did here. That is what we did here, and that's that, right? So, it's a pretty powerful tool. This process. It's pretty easy to do, too. All you need to do is just plug and chug, and that's that. That is that. So I worked out the equation just so you can see, but you don't need to do that on a test, I promise. I would just, write it down and use it whenever the context needs it, and that's that. So I will pause the video and we'll move on to the next example question.